Okay, so our next speaker is Dimi Racordon. So Dimi is a researcher at EPF Files LAMP group in Switzerland, working on type-based approaches to safe and efficient programming. Dimi leads the Hylo project, exploring mutable value semantics and language design. So today, Dimi will talk about the origins of the project, early design decisions, and the practical and social challenges of keeping a language project alive and thriving. So let's welcome Dimi.
Thank you very much for the introduction. Yeah, I like to give some of my very little wisdom designing this project. So what is this project? Well, Hylo is a general purpose programming language, but we target mostly systems programming. So you can think building compilers, building graphics engine, things like that. So low latency applications. And we have three main goals with Hylo. We want it to be safe by default, in the sense that it should be free from undefined behavior. That's a condition that occurs when the preconditions of your unsafe language is violated, and that lets the program do theoretically anything. We want it to be fast by definition, and what I mean by that is that it should be possible to build complicated and sophisticated abstractions without loss of efficiency, or at the very least with strong guarantees from the compiler about the efficiency of your application. And finally, our goal is also to offer a language that has a lot of high-level features, the cool toys that people can use in Scala and Haskell, and that's usually gate-kept from people doing low-level systems programming. We want to provide them also, and we want to do that efficiently. So these are a lot of goals, but I'm not here specifically to talk about the way that we want to do it. I just want to maybe give some information about how we achieve those goals, because that will give the direction. This is like a sort of introduction to how it all started. So Hylo is based on this idea of mutable value semantics, which in a nutshell is a discipline that's about upholding the independence of values and to keep references out of front-facing users model. Right? You program without references, you only have values. That sounds a bit like functional programming, pure functional programming, but we want to keep mutation around and explain why. So I could talk about MVS for hours, but I will do a very brief introduction and focusing on one aspect that MVS gives us is local reasoning. And to illustrate, we can look at another programming language. For instance, here we're looking at Scala. And in Scala, like in many other languages, for instance, JavaScript, when we call a function, the arguments that we get are referenced to shared objects. So there is no way to reason locally, really, about a function, because it might be that v and d alias each other. And when that's the case, the behavior of the function that is documented here would be incorrect. And we can observe that it impacts our ability to do, for instance, function composition. If I write this very reasonable upset twice implementation, it's actually wrong. If I call it on a pair of views, then I get 10 instead of 7.5, which is obviously wrong, right? And the bug here is not exactly easy to spot if you don't know where to look. And this is only like a 10 lines program. So you can see that this problem scale with actual code bases. So if you're in a reference-oriented language like Scala or Java or Python, or JavaScript, there are not that many ways to solve this issue. One is to, well, properly document your functions, but that's barely a real solution, because compilers typically don't enforce comments, although we have seen very nice specification extraction today. But also, if you forget to put a copy, then you get the bug, and if you put too many copies, it gets inefficient. So the other approach is to just give up mutation and you just use immutability for everything. But that's an approach, and that's an approach that is quite popular, right? Very smart people advocate for this thing, and we've seen a push to go toward immutability in many languages. In JavaScript, over the years, I acquired a lot of interesting tools and libraries to develop code without mutation, and this is also a push we can observe in other languages. But the issue of pure immutability is that we've been sold that we could just rely on optimizers to get back the efficiency of the real machine, because the real machine is most of the time imperative. But I think it's mostly a lie, and there are many evidence we can find everywhere. But I can also shamefully just push my own research here. These are results that we measured on randomly generated program doing various sorts of mutation. And what we can see is that the pure functional approach used by Scala here is it's lower than what we have at the bottom that is using MVS with Swift. And if you're wondering why C++ is that slow, it's like because in this particular experiment, we were also showing what is the cost of doing too much copy. And C++, if you don't use references as a copy, pass-by-copy semantics by default. So, okay, and this value semantics thing is nice. You can rewrite this offset function. Swift has this in-out keyword, basically means the value moves in and then it moves out at the end of the call. And then you have a nice step system on top of it that guarantees that you cannot create this aliasing situation. And so if we translated the program in Swift, we get caught by the compiler here. Okay, that's very nice, but that's not necessarily the point of this talk. It was just introduction. What's interesting is that we studied all of that. So myself and a handful of other very nice people in a paper that was talking about valuable strategies for mutable value semantics. And in the context of this paper, I wrote a compiler for a tiny subset of Swift that was meant to show that you don't even need to pour a lot of engineering effort into making an optimizing compiler once you adopt this particular discipline. And as I wrote the compiler, I just started to acquire some ideas of things that we could do in another programming language that would be even more dogmatic about MVS and Swift is. So a true support for value semantics. And these ideas kind of coalesced into the design of a toy language. And I talked about it to my co-authors, and to my surprise, they were actually quite excited about it. So in particular, Dave Abrams. Dave Abrams is one of the person behind the Swift standard library. Also spent a lot of time working in the C++ standardization committee. He's the person responsible for move semantics in C++. So kind of a smart guy. Said, well, maybe we should do it. At the time, he was working on trying to improve the life of C++ developers by pushing ideas from MVS into the language. And he said, yeah, maybe like designing a research language, an academic language, might be a good idea a good way for us to show what we mean by value semantics and what kind of improvements we could get from value semantics. So you should definitely do it. And I say, yeah, but it's a lot of work to develop a programming language. So, yeah, maybe I can help. And so that was enough motivation for me to start. And about 4.5 years ago, I wrote the first commits. I'm actually relatively proud about the name of my first commit here. I decided to fight another dragon with a reference to the Dragon book. And at the time, I thought it would be like a short 6-month-ish project, not something very serious, just to do improve the tiny compiler that we had made for our paper and to make it into a coherent design. I'm very, very bad at estimating how long things take, but also to be fair with myself, the project turned into the real deal, about 2 years in, when we thought we actually were designing a real programming language and that people were actually sort of excited to use that as a real programming language, not just as a repository of ideas to take apart. And so long story short, we eventually designed this programming language. It's still under development, but I think we reached an interesting point. So now that I've fought the dragon for more than 4.5 years, and it's still not completely slain, I have maybe a handful of unsolicited advice, piece of wisdom that I like to maybe share with people who may consider joining the fight as well. So my first advice would be don't do it. this is way too much work for a single person to do. Even if you surround yourself with very nice person, it's really too much work. And I'm not completely convinced that it's worth it. It's very fun, but you need to know that if you decide to do it, you're in for the long run. And I will also encourage you to watch this amazing talk from Evan Czaplicki. He's the creator of the Elm language, and he has to talk about the economics of programming language, from which we know that this is a sort of area where basically it's very difficult to find money. Not many people are ready to pay for the development of a programming language. We expect a lot from the open source, and we expect a lot from the language and the tooling around this language. We've seen some tooling today around specification, but obviously you also need an IDE, you also need a package system, refactoring tools, documentation. You need all sorts of things. So if you want to push an actual programming language, you're not just building a programming language and a compiler, or even just the specification of a language, you're building this entire ecosystem, or people are expecting that you build this entire ecosystem. And I think this is just an unreasonable goal to try to achieve unless you have undying motivation for doing that for the foreseeable future. Now, from personal experience, I would add that especially if you, like me, want to have an academic career, another thing to consider is that it's very hard to publish your work if you're developing the programming language, because academia cares about IDs. So you might be able to publish the IDs of your language, but they usually do not care that much about implementations. And implementing a real programming language is a lot of implementation work. I do believe that there are interesting things to say about the implementation of industry-ready compiler, but it's much more difficult to publish in your standard PL venue. So this is also something to consider, because it will significantly slow down your career, right? Whereas people, your colleagues might be able to send IDs with abstract formal syntax. You have to actually write a parser that is able to generate nice error messages and just time, right? So this is something to consider. But okay, I probably should not be that negative about it. I did like my experience so far, and there are people crazy like me, I'm sure, will not care about this first advice. So if you do decide to implement your programming language, then my first or first plus one advice would be to get a clear sense of what is your target audience. General purpose programming language is a term that we throw around a lot, but I don't think there actually is a truly general purpose programming language. It's just language have niche, and people, they love their language so much that they will just try to use their language outside of the niche. But for instance, I would not consider C++ to be a general purpose language. It's certainly a language that lets you do anything you want, but it's a language that has a target. So you should identify this target, because this is the target that you need to advertise to, and that you need to listen to if you want to understand what are the pain points and how you can help them, and what your language can actually contribute to that audience. If you just try to aim for total world domination at first, I think you might lose yourself not identifying properly what you should do. So for us, the target audience was actually C++ developers who are currently in search of a successor for C++, which is a very complicated language and that has a lot of difficulties progressing for various reasons. Maybe we will get some insights later today from when Jaco talks about the standardization of C++. But anyway, this is a target that we have. It shares some overlaps with people doing systems programming in like Rust, in like C, and it's an interesting niche, right? It is a niche. You will not appeal to people doing web services on Amazon instances with your language if you are doing something like Hylo, but you will have people who have like deep pain points that they want to address, and you can entertain this discussion. So I think it's the first step. You need to identify the target, and you need to understand how you can help this target solve their issue. The other advice I would say is surround yourself with cool people. I mentioned Dave already, but there are many others who helped designing Hylo from the early days, or who are now who kept along for the ride and are now contributors. We have actually a relatively big community for a language that is that early in its development. There are 100 people on our Slack. Obviously, not 100 people are constantly here by shading the every feature of the language. But we have a lot of people gathered around this project, and that helps a lot. That helps a lot for different things. First, you get other opinions. I don't have the pretension to think that my ideas are always the best. So it's very nice to have other people contributing ideas to solve my issues for me. You can get confirmation, or you can read the temperature, right, when you propose some features, and see what other people think. And it's also sort of emotional support, right? As I said, it's a lot of work. It's not always rewarding, but when you have people sitting next to you in this big project, it's also very nice, like to know that you are doing something that other people care about, right? And then it becomes more than just your pet project, which I think is difficult to to just maintain alive for years on end if you're alone. So surround yourself with people. Don't be afraid to share your ideas, and don't be afraid to dilute a little your own directions with what other people have in mind. But it's a bit easy, I think, when you design a programming language to fall into the trap of wanting to design your exact own thing without considering what others want. And yeah, then you get to design your own stuff, but you also get to do it on your own, which is not that's so nice. Speaking of ideas, get your ideas out. I think this is a sort of general advice we could give to people in academia. I don't think people fear that much anymore that their ideas would be stolen. But this is also something that sometimes I've seen speaking with other language designers. You get once you invested a lot into your thing, you might be scared that you will just be swept by having your ideas pulled into another competitor language. But I actually don't think that is a like a real fear. Languages have a lot of inertia. It is very difficult if you have radical new ideas. It's almost impossible that your ideas will be picked in another language without you having shown that it actually works in practice. So for instance, if you take Rust and you say, oh, I have a much better idea for doing lifetime annotations or stuff, you will not change Rust, right? People have a lot of inertia. They put time, money, emotion, efforts into the system that they have. So they just don't want to change unless they see that you do, in fact, have something nicer, which would be proof if, for instance, you can actually make your thing work. So show your ideas and show how it could work in other languages as well, right? Don't get stuck with just your language. If it's a PL ID, it should transcend a single programming language, and so you should be able to show to show how it works in other languages, which is very nice in papers because then you get to publish your ideas, which is simpler in academia, but you also get to kind of sneakily give credence to the fact that your project is actually necessary, right? Because you can say, well, it works well, this stuff in C++, but we can see that in C++ we are constrained, so it would be actually nice to have a better language in which all of these issues that I expose with my DSL in C++ are limited by the language. Here, I would like to recommend this presentation to as a keynote from Jan Vitek in 2020. I think it was eCoop 2020, where Jan talked about how you can hack academia to build the stuff that you want. And this was a very instructive talk for me because I think this is what I've been doing ever since, is this idea of painting your ideas packaging the things you are doing into nice ideas that you can put in papers. So do that. I think it's I think it works. Jan was onto something here. And if you do that enough, and you have half decent IDs, then eventually you get followers, and I think you can even get fans. So that was here an example. It's a random post on Reddit talking about C++. I said the community was C++. And this person that I really don't know here said that they would bet their arm that Hylo is a sound system. This was before we had any proof of soundness. So I was not sure that they should actually bet their limb, but it was very nice. Again, it's convince you that you are helping, or at least you might be helping people, and it's emotional support. It's advertisement for your language. It's emotional support for its designers. On the flip side, you should also get prepared that if you get some momentum, then it will put some pressure on you. And I do not want to disappoint this person, so I do hope that Hylo is sound. And it also puts pressure on you to finish the project, to have something running, because you have people like investing in you in a sense. And that might be pressure that you also need to kind of manage in a way. Then on the topic of more like specification, because all of the social aspects are not directly tied to the topic of this workshop, I would say that it's very important to design, implement your IDs, test your IDs, and then repeat this process in a very tight loop. I don't think that you can just write the entire specification at once, and then say, okay, now I have my coherent design, let's just implement it. I strongly believe that you need to have this iterative process, and that specification and implementation should feed into one another. There are nice ideas on paper that are totally impractical to implement, or just don't work when you test them in practice. Right? It was nice on paper, but actually it's terrible to write any line of code in this language. And so back to the drawing board. And this is something that you cannot necessarily see by just doing formal specification. Formal specification, we have the math, we stash a lot of things in our environments and say, yeah, gamma judges that, blah 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 blah, and say, okay, but how do we build the gamma thing? This is something that you can only realize by actually implementing. And of course, if you focus just on the implementation, as we've been told this morning, you are at the risk of building the wrong thing, and then maybe your entire system isn't sound, and people might lose their limb because of you. So I really think that you need to do this very tight loop. And to be fair, this is a lesson that I didn't come up myself. I learned that from this nice paper. It's a report on lesson learned from designing Mezzo. It's a programming language from early 2000. I don't think Mezzo really survived. It was like a PhD project, as far as I remember. But nonetheless, I think it was a cool idea. But more importantly, in this paper, we are being told that syntax does matter. Like the concrete syntax does matter. It helps understand if your cool ideas on paper actually scale in the real. So in the real world. So I would encourage you to do that. Do this very tight design, implement, test, and repeat loop. Also, very important piece of advice, I would say, is to say no when people come and ask you features that you do not like or do not want. You should get used to people coming and ask for a lot of features, and it's not necessarily surprising, right? We constantly ask mainstream languages to have a lot of features. This is a long process. It's very difficult. It's easier to just go to a tinier project where there are only, I don't know, 5-10 people working in it. There is no official process for specifying and implementing new features. And so people will ask for syntax changes, platform support, type system stuff, anything that their hearts desire. And it's important to listen to these requests. You have an audience, as I said. You need to understand the pain points, from where they're coming from. But you should also not try to be a people pleaser, right? You should have a vision. and stick to your vision, because this is most likely you're kind of right, at least in doing your vision. And maybe your vision is wrong, and then your language is a failure in a sense that it doesn't solve the problem that you were thinking you thought it solved, but you don't get distracted implementing things that are not part of your mission. When I say that you should say no, no is not necessarily permanent. If you asked me a year ago, for instance, I would have said that macros were one of these hills I'm ready to die on. I would not have macros in my language. But this is something today I've changed my mind, right? So maybe because the project is moved a little along, or because I've seen it work in other languages. So saying no doesn't mean that you need to be dogmatic. It just means that you should be focused on your priorities, focused on the mission that you have and what you want to achieve. And the last piece of advice I would have is to just have fun, right? It's a lot of work. It's a big undertaking, so have fun doing it. Meet cool people, go to conferences, go outside of your bubbles, try to show your language to other people, try to show your project, try to be a bit controversial, go to other communities once you have identified your audience, go to other audience and challenge them to also like stir up conversation and have fun building building these languages, which I think are a true delight once you get to some point and your language is getting momentum. It's really rewarding. So yeah, that was the sort of very little wisdom that I had for you. And if you have questions, I'm happy to take them.
Thank you very much. Questions?
Thank you, Dimi. This is Jaakko. Hi.
Hi.
Very nice talk, very inspiring. Maybe two questions. First one is you gave this advice, like don't do it. Would you follow your advice if you would be studying now?
No, I would not. I think I have too much passion for the thing. So yeah, I would not follow my own advice. So take what I said with a grain of salt.
The second advice is, can you tell a little bit, question, a little bit about the next plans, like where you are heading now with Hylo?
Yeah, so we reached the point where we have something that is serious enough to be able to go to people and say, hey, in like half a year, we probably have a preview version of the language. So now it's a matter of trying to convince real people in the real world to use it for real stuff. So that's what we are trying to prepare currently.
Yeah. Okay. So first of all, thank you for the talk. Second, thank you for the mutable value semantics. And I have a bit of a provocative question. Like at several points during the talk, you said that like this and this and this puts the pressure on you to finish the project. If you can share the insights how you finish a programming language design and implementation, so that like we know how we can stop and finally go on with our lives doing something else. That would be very interesting.
Yeah, so I will go back to my first advice: don't do it, right? Because it never ends. I think you can identify milestones where you think you have solved a problem, and then sure, you can always improve on everything, but maybe this is there is a point at which you can think that it might be others people's job to do the improvements, right? You've done the groundworks, you've set up the system, and yeah, there are cool other stuff that that could be done, but maybe this is work for someone else to pick. And so in that sense, you're never done with your design. Otherwise, it would be sad, right? And we would lose all of our jobs, so it would be terrible. But you can move on with your life. You can pick another fight. You can pick another dragon, and you can let the dragon that you had started with to be the fight for other people.
Thank you.
Any other questions? Yeah.
I guess it's less a question and also more a comment. I also want to back up that, like, your first advice, don't do it. So, because, I mean, you said some of that, right? Like, designing a language and building a compiler is actually a fraction of the work you have to do is to establish a language. You have to actually build an ecosystem. Nowadays, people expect so many things from a language, like IDEs, libraries over libraries. So I haven't seen Evan's talk. Maybe I should look at that. But I've attended a talk with, I think it was by Luke Church, some 5-6 years ago. That was not public, unfortunately, but he attempted to do some data mining and trying to reverse engineer how much, what the cost was of certain languages and establishing them. And he came up with, like, for C#, he came up with numbers that were in the billions. So the investment was in the billions from Microsoft's side just to release C# 1.0 and probably several times that for the versions after that. So that just is going to show, like, how massive an undertaking it is to actually do a language. So I mean, by all means, do it if it's a fun project, but don't expect to be able to actually establish a new language necessarily. That is like one in a million sort of. Yeah, and I have followed my own advice.
Great.
Any more questions? Maybe I have a short question. So you mentioned that it is expected, and we all understand it. It is expected to have tool support for a language. But, like, how early should we start? So, say if you have a very initial implementation of the language, should we start taking up on an IDE?
That's a good question. I would say the moment that you are able to write a program that is more than 4 lines, so the moment that you can write a program longer than what you would just write in a paper, I think you should start thinking about tooling. For several reasons. The first is that you will write your standard library, hopefully, and you want quality of life for yourself. Right? So I want a debugger because I do not enjoy print debug the implementation of array. So that might be a good reason for you to have the tooling. And also you want to make sure that you, like, if you're here for the long run, right? You want to be sure that you also design your tools in a way that it will be possible to create this tooling ecosystem around it. There are many ways to write compilers. You can write a hacky compiler that just gets the job done. You can write a compiler that produces nice error messages. You can write a compiler that is extensible by a language server thing, blah, blah, blah. So if you are here for the long run, this is also things that those are also things that you should get into the process relatively quickly. So I would say once the first iteration lets you write a 100 lines program, then it's time that you have toolings.
Thank you. Yes, thank you very much, Dimi.
Thanks a lot.
So now we have lunch break and we continue at 2.